Good morning, everybody, ladies and gentlemen. Welcome to the International Surgery Conference, and greetings from Edge Hill University and greetings from the UK. Before I begin, I'd like to thank Professor Amin Nisar for inviting us to this conference. I'd like to thank Professor Hanif and Professor Dr. Naeem Zia for arranging this conference and having us here. So, I am Engineer Abdullah Farid, and with me I've got Professor Yanis.
Hello everybody.
Yeah, he's Greek and he's the top gun here. He knows so much about AI. He's the head of department. And Professor, what else do you do here?
I'm the Director of Postgraduate Studies.
He's the director.
And I am the Director of the Research Center for AI in the department.
He's the Director for the Research Center of AI, yes. Okay, perfect. And he's Greek, and I'm sure his Greek ancestors would be so proud of him. He's definitely living up to the name of his race. So before we begin, I've got this quotation from the book The Alchemist. When we strive to become better than we are, everything around us becomes better too. So one of the ways we can better ourselves is by working with people from different fields, like working in a cross-functional team and learning from each other. And I think the medical community can actually benefit by working with engineers, and I'm so very happy to see that so many doctors are now interested in AI, and I think it's a good move. So all of us, I think we should strive to become better, and one of the ways is to look into other areas of life and other fields. So the topics that we would be discussing today is at first we've got a little bit of introduction, then we'll answer what is AI, we'll discuss the types of AI, we will look into machine learning, deep learning, natural language processing, computer vision, robotics and automation, and then we'll talk about AI in business and finance, AI in education, AI in healthcare, AI and surgery, and then we'll conclude. So for the sake of it, let's look into the definition of AI. What is AI? So AI, or artificial intelligence, it refers to the capability of a machine or computer system to perform tasks that typically require human intelligence. So if you've got a machine which is able to perform tasks with human-like intelligence, then we can say that it's an artificial intelligent machine. Can we say that, Professor?
Yeah.
Yeah, okay.
A machine with artificial intelligence enabled, yes, you would say that.
Okay. So let's look into the history and let's see how we've come this far and how do we have AI now, and let's look into the evolution. So human beings from the early ancient times, they've always wanted to have artificial beings who could think like us, who could talk like us. It dates back to the ancient mythology. But in the first recorded history, I think it was in the 17th century, that we had this philosopher Descartes who explored the idea of automation and the possibility of creating machines with capability of human-like reasoning. But it did not manifest in the 17th century, and this was because of the limitation of the technology of that time. And one of the notable person I'd like to mention here who really contributed is Alan Turing. I think his work laid the foundation of the modern computers and computation, and because of his work and the computers that we have now, we can work on AI. So when did AI actually begin? So it was in the 1950s. This scientist John McCarthy, he was the person who coined the term artificial intelligence in the Dartmouth conference, and in 1956 it was the first time that we had artificial intelligence as a field of study. In the 1970s, we had a bit of a dark period. We had this AI winter because the engineers and entrepreneurs and investors, they were overambitious, and they wanted outcomes straight away. And the computers of that time, they were just not ready. They did not have much memory. They did not have much processing power. So there was a lot of pressure on technology, and because it wasn't ready, we could not get the results. So the funding sort of rolled back. People stopped talking about AI, they stopped looking into AI. But as we move forward towards the end of the 1980s, our computers, they started getting better. And we started seeing a re-emergence of interest in AI. And then we moved forward toward the 1990s when we had computers like 486, 286, and that was the time when we also see a rise of interest in machine learning. Machine learning is a subtype of AI, and moving forward from I think 2000 onwards, it was actually in the internet era when we actually see some major breakthroughs in AI. Because of the internet, we had we were able to extract a lot of information. The computers also improved, and the systems improved, and we were just able to work more and more on AI. So, what is artificial intelligence? So, AI refers to the simulation of human intelligence in machines that are programmed to think and learn. And let's look into the characteristics. So, for a system to be artificially intelligent, it has to have the ability of learning, reasoning, problem solving, perception, language understanding. There can be more, but these are the ones which are the main ones. So we've got the types of artificial intelligence here, and we generally divide this into two, which is the narrow or weak artificial intelligence, or general or strong artificial intelligence. So in weak AI, an example could be like a chatbot. Like you ask the chatbot, "Hi, how are you?" It's going to look into the text and into the words which you've written, and it's going to look into its script, and it's going to come up with an answer based on the input that you've given. But the problem with chatbots is that they do not have indigenous thinking. Like if you want to talk about trees, they will say, maybe look outside the window, how many trees can you see? But they will not come up with anything original. Or in other words, we can say that in weak AI there's no consciousness. And as of this day, even in 2024, we do not have strong AI. Strong AI is having true consciousness, and although we are moving in that direction, but we do not have it as of yet in full. So let's talk about machine learning. And machine learning is a type of artificial intelligence. It is a subset of AI. So in machine learning, we are basically dealing with algorithms, and we are dealing with data sets. And it's like we have this machine learning system where we feed the experience into the system. Like the data set is sort of an experience for the brain of the machine learning system, and based on the experience, the machine learning system is going to give some outputs. An example could be, let me give you an example from the medical field. Let's say we want to predict if a person is going to have diabetes or not. So we obtain a data set of, let's say, 1,000 patients with different features like BMI, age, and their ethnicity, their blood group, etc. Like whichever we feel are the features that are important for talking about diabetes. So we input all those features and the data set into our system, and then we have a new patient which comes in, let's say a boy, 25-year-old, and we input the features of that person into the system, and our system would be able to tell, okay, this person has BMI of 30, he already has hypertension, so there's a 90% chance that when he's 40 or 50 years old, he's going to have diabetes. So this is a very, very basic example of machine learning, and we can basically divide machine learning into supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, what we do is we give the data set to our system, and we also give some instructions. It's like supervised. And in unsupervised, there are no explicit instructions which given along the data set. The system has to learn on its own. And in reinforcement learning, what happens is that the system is continuously engaging or interacting with the environment. Like they are, it's like a point-based system, like where you get rewards or where you get penalties. I'll just give you a funny example where, like, if you give your wife a gift, you will get a reward. But if you forget her birthday, you're going to have a really bad time. So you'll be penalized. So these are the types, and this is the part where I hand the session to Professor Yanis. because the topics which are coming from here on, they are very tricky, and I would really want him to, explain them.
Thank you. So in this slide we can see a neuron in a human body, which is the inspiration for neural networks, for the neurons in neural networks that we see in neural networks and neural network-based systems. So deep learning is the field of AI that uses neural networks. In human bodies, we have neurons communicating with nerves and other links to the external environment of them. So that is the inspiration for a neuron in deep learning. It has inputs like in1, in2, and in3 in this image, and there is a function, there is a summation of these inputs and a function that sometimes may produce some output that you see coming out of the other end. That's the core of neural network-based systems, and these neurons are then combined in groups and in layers, and this is how systems are building this level of artificial intelligence that you have correctly called somehow weak. Okay? Yes. But we are moving towards a more and more advanced, a stronger and stronger level of AI nowadays. Yes. Right, here are some examples of systems based on deep learning, such as ChatGPT, which I guess you will all have a first experience with since November a year and a half ago. It's based on an LLM, on a large language model that uses natural language processing. So it processes text and learns the links and habits of words to be next to each other. So its power in producing new text for you is not a real cognition, it's not real consciousness. It's only out of observation how words occur next to each other, what are the links between words. So then in the answer, it starts producing new text for you as you go. And there are other products like Midjourney and Pika here, later in this slide, that do similar synthesis but in a non-textual level. For example, Midjourney does that with art images, producing images like the one you see on the right-hand side of this slide. And Pika does even more advanced things, producing synthesized video, animation, images with motion, and things like that, out of inspiration that may come from text, images, or even video. So these are deep learning products that you will all have experienced nowadays, I guess. The basis for that is, as I said, natural language processing, especially for LLMs, the ones that are used in ChatGPT and other similar models. Other applications of natural language processing involve chatbots that you will have used with your banking on your phone, with other mobile applications where you talk to a chatbot and it gives you suggestions on what to do when you have an issue. Language translation, systems that automatically translate in other languages what you are saying. Sentiment analysis, an automated process of measuring the sentiment that is expressed in text, in a product review, maybe in the review for a hospital, in the review for the experience after surgery, for example. You've got virtual assistants that can welcome you in websites or in real life, in-person experiences, and tell you, give you some bit of information that you may need, and also information extraction. As doctors, you may have seen in the past the cases where we want to extract certain terms from documents, like named entities, proteins, DNAs, RNAs, all of that, and link them together to see how different papers link with each other. So extracting this automatically involves natural language processing and is an information extraction task. Why am I saying all this? I'm saying all this because I want you to understand the capabilities of natural language processing as a technology that was then used for large language models. In another area within AI, computer vision, we can do similar tasks but on a different input. The input here is images. We can detect objects such as the buses and the vans in the image in the top left corner of this slide. We can identify faces like the image on the top right hand side of this slide, where you can see that an algorithm has identified special points, some points that are very important for the face of this person. And you can see the distances between the nose and the chin, the cheekbones and the forehead, and so on. This, apart from identifying the face, helps us to identify what the face is doing. So, I mean gestures. What's the movement of the face? Is the face happy? Is the face sad? We can identify expressions of sentiment shown on a face. We can segment images as well if we need. For example, if we are interested only in the bus, in the red bus on that image on the top left, we can cut it out and crop the image only to contain this. We can build categories of images and video because we can identify things on the images and things on the video. Then we can say all the videos that contain cars should go in that folder, or images that contain faces should go to that folder, and so on. This can also apply to medical imaging as well, if we want to automatically identify elements on a medical image or categorize them as having or not having a particular condition. Of course, because this is an automated tool, this kind of application would only be an aid to doctors rather than a decision maker when it comes to medicine. Robots use computer vision because they wander around these days at home or in your professional environment and may identify objects or humans, may say hi, may navigate around tables, and so on. Similar applications we've got in autonomous vehicles that are still in pilot phase. Some companies have produced some, but still it's a technology that's not fully out there. As you can see in the image at the bottom right corner, cars can identify the environment around them, communicate with other cars, and navigate in a safe way towards the destination. Robotics and automation has a huge area of application these days. It has been applied in constructions where robots and drones do certain tasks. They can deliver objects and items and tools. They can inspect a site from high above and in essence help the process and speed up the process as well. In retail, we've got AI-powered robots that can find your product in a huge range of shelves in a big factory, put it in a box and send it to you at home much faster than humans would do. There is always criticism as to the number of jobs that are being lost in this process, but I will leave this out of the discussions just for the sake of time. In agriculture, we've got drones that can inspect fields, measure the level of moisture, measure the needs of plants for certain substances, and this will speed up the process and the performance of agriculture these days. Similarly, with logistics and warehousing, robots can navigate in the warehouse and find things or tidy things up. And in manufacturing, we can have factories like the one in the bottom left side of this slide, where robots know exactly what they want to do in the exact correct order and carry out very complex manufacturing tasks, such as producing cars. So now in the following slides, I will be mentioning applications of AI in various different sectors in real life. You will be seeing a lot of items, a lot of terms in the slides. I will be only commenting on some for the sake of time. So in business and finance, we've got plenty of AI applications automating business processing in general. Everything that has to do with tidying up paperwork, working collectively as a group, working remotely, synchronizing the work of employee A with the work of manager B and so on. It can all be speed up with AI. At the next level, at the decision-making level, predictive analytics are very important because AI, as we discussed, can identify links between events, links between data scattered around, and the level that AI can do this is beyond the capabilities of people and sometimes groups of people as well. So predictive analytics has a big power with AI because it can collect a lot of information, make a much more well-informed conclusion, and maybe be useful for making money, for lowering the risk, for identifying fraud, for example, in banking, for personalizing the services that a company offers, or the products. Identify, for example, that you have just bought this suit and you were interested in white shirt as well, so most probably you will be interested in a pair of shoes or a pair of trendy gloves, and you will automatically receive advertisements about those. This is a result of AI analysis. Supply chain can also be optimized because we can improve the transportation between the depot and the various stops in a series, in a trip of a business car. Human resources as well, and I won't talk about everything, but you have now already seen that it has huge applications in business. Now in education, learning can become a lot more personalized. Each student can see immediately the level of exercises and the level of content that matches their ability, because there is a system at the back measuring and identifying how a student is behaving. So it automatically adapts to the content they need to see to improve. Adaptive feedback is also another interesting outcome. So feedback that's automatically generated for every student. Gamifying learning is another good aspect here, where instead of telling a student dry knowledge, 1 + 1 makes 2, why not having a game around it that makes it easier to digest? In healthcare, now coming closer to your interests, diagnosis has a lot to do with data and with identifying, noticing similar patterns among a group of patients. So AI can help with this because it can process collectively huge amounts of data at once. It can also identify similarities between people, between patients, so that you and companies in healthcare provide personalized care for each one of the patients, rather than following one rule for the whole range of patients independently of their characteristics. Patient management as well, if we're talking about a hospital or a particular facility, the way that patients move around, the way that patients experience the environment can be improved a lot using statistics and data processing involving AI. Natural language processing can help as well because there is text involved in this. Patients provide text, doctors provide text, and in the side of patients, we may be interested in automatically identifying what did they say we did well and what were the problematic areas. And coming to the side of doctors, we may be able to identify exactly what are the conditions and the medicines that they have mentioned in a paragraph of diagnosis report that they may produce after seeing a patient. If we identify this automatically, then this speeds up the process of patients getting their medicines quickly, of doctors classifying that particular case together with other similar cases. In general, the administrative part of healthcare, and there is a lot that probably doctors realize to some extent, can be faster and more efficient with AI because of all of its ability to deal with paperwork efficiently, put it in groups, identify similarities and stuff. In recent applications where we've got patients at home and doctors checking on them remotely and suggesting changing or improving their care remotely, AI can be very useful because it provides facilities, it provides tools for and sensors for monitoring, and also improves the communication between patients and doctors in that remote setting. Now, let me try, this is just an attempt, of course, you will be the experts of the field, but let me try from my side to say how I see AI being applicable to your field, to surgery. Maybe you can use it for pre-operative planning, so to plan how you're going to carry out an operation. How does this patient that you are about to work on look similar to other patients that you've worked with in the past, you or your colleagues? And what are the known complications, the challenges when you're dealing with these patients? So it's, I understand, always important that you know about this before you start an operation, and AI may be able to help you in that. It can also help in analyzing images that you may have during an operation, and again, because it has all this ability to identify similarities with lots of other images that it has seen in the past, it may help you in suggesting what the problem is in each one of the images, or how this image relates to particular conditions. Robots, you will already be using those in surgery. Some of those have AI components that suggests movement, suggests special solutions that you may take into account during surgery. Excuse me for not being super knowledgeable of this field. You will know better. Surgical navigation, I know, is the way that during surgery the tools of a surgeon move within the human body. This may as well be improved with AI. Predictive analytics is another big area of AI because, again, of its ability to identify patterns in a huge sea of data. And this can help you make decisions. So, for example, if you've got an image, if you've got the results on the tests of a patient, and you are trying to diagnose, sometimes you are 100% sure that's fine. But in some cases you may be wondering, so what if you were able to compare this with thousands of other cases with similar characteristics in the past? AI won't make conclusions for you, but it will provide you with a background of knowledge, saying that, look, in these 1,000 cases, in 220 of those cases, this happened. That was the reason, and this is how the patient progressed after a certain point. In this big block of 500 cases, this other path was followed, and so on and so forth. So you make the decision, but the decision you are making is a lot more informed when you've got all this report from an AI system. It can also be useful for training, of course, and for integrating diverse types of data. For example, if you've got text and images and video around a certain surgery, you can synthesize them together and process them together so that you can collectively extract meaning from the collection rather than each one of those in separation. I hope you found this useful. I hope that our quick discussion today got you thinking, gave you ideas, and maybe opened the field of AI a bit more to use it in the future. AI is an old idea and it has just been relaunched. However, now we see that there is a lot of potential. There is a lot of sectors using this technology and its products everywhere. Maybe there is potential for surgery as well.
Definitely. I must say there is potential for AI in surgery.
Okay? And with this, we will conclude our talk. Thanks very much for your attention. Please see our email addresses at the bottom of this slide, and we will be very happy to respond to any questions you have over email. Thank you very much.
Thank you. Bye-bye.